In this section, we're going to cover some of the tools and services available for cybersecurity. We've talked about a manual process of detailing what's in our system. There are many ways to find the vulnerabilities, understand what they are, and try to protect ourselves. But what if we actually had automation software that could do that for us? So if it could ingest what's in our system and then provide us with findings. So it can actually provide us that it's found 8 assets with unpatched vulnerabilities and 13 assets that have multiple network innovations, something that we know is potentially risky. It can highlight those for us, or unsecured protocols, security alerts. So if it's actually finding someone doing something like a port scan that is typically preceding an attack, it's going to highlight those for us. So I want to talk about a partnership between Clarity and Rockwell Automation. Clarity is not owned by Rockwell. Rockwell is somebody who works with Clarity, they're partners, but other manufacturers also work with Clarity. This is something that Siemens has invested in, that Schneider has invested in. So it is an open platform. It's not Rockwell specific. It's going to find a lot of vendors' information and provide visibility specifically for OT products. So specifically for the products we use, automation, that's where the OT comes from. So instead of it being an IT and information technology-based protocol, it's meant more for an automation system to understand exactly what our needs are and what we use. So Rockwell and Clarity work together. Rockwell's invested in Clarity to give a system that'll actually do a lot of this work for us automatically. So with that, I'm going to show Clarity here. So Clarity is a server, or it's a software package installed typically in a server on site, and it can have multiple instances depending on how it's done. But what it's going to do is it's going to sit and monitor and understand the network. So it's going to get a baseline. It's going to learn how the network should operate for a few days. With automation networks, fortunately, they're pretty predictable. Once a system is up and going, there shouldn't be a lot of dynamic changes to it. An IT network is entirely different. People are walking on with their phones and plugging and connecting and disconnecting and plugging in their laptops and leaving, and you have visitors. Automation networks shouldn't be like that. Once you program a PLC to talk to a variable frequency drive or a PLC to talk to some remote I/O, you would dictate how often it's going to communicate, how it's going to communicate, and then you would set it and forget it. And it's going to do that again for years and years and years and continue that communication. Now, you might add new assets over time, but you're typically not going to be adding and removing with the same devices on a daily basis. So what Clarity does is it learns the baseline of the system. And then once it goes from the baseline mode to the running mode, it'll actually start showing you variations from that baseline and capture a lot of the information that we've already talked about. So what I have here, for example, it's found all my assets. It's telling me I have 51 PLCs, multiple HMIs. It's going to give me an overall hygiene score. How is my network doing overall? And then some top alerts here, top insights. But if we dig these in a little bit more detail. So if I show you, there are multiple ways to find all the assets within the facility. One would be, there are some crawling tools. We do something called an installed base evaluation where we go physically look at all the equipment within the plant. And there's still some power to that because it shows us exactly where things physically are. But from a software perspective, there are multiple tools that can actually capture all the information for you as far as what devices do we have inside of our plant. So here's a list of all of our devices. So it's going to give us the IP address, the MAC address, what type of device it is. So these are a bunch of cameras in this case. It's going to give us the vendor, so who made it, and the risk level associated with it. So if I can also add some additional information that it's going to find. So firmware, for example, depending on the manufacturer. Let's actually select Rockwell. So if I look at some of my Rockwell devices, here's a PLC it found. It has a high risk level associated with it, and it's going to give me the version of the Ethernet module that it found. If I click on one of these, It's going to give me more information about that device. So it's actually discovering a lot of this information, typically passively, typically by listening to the network. There are active ways that this can go out and scan the network. But from a passive perspective, it can get a lot of the information. So this is the detail we saw earlier, the firmware of the Ethernet module, the serial number, the type of device it is, manufacturer, and the criticality. Some of these you'll see we can adjust for our system. But then it's going to give us information, the risk level for this device, some of the analytics on the network utilization. It's also, this is powerful, going to give us exact information about what else is in the chassis. So anybody familiar with control logics? It found the Ethernet module, but it's also going to give us information on the processor. So the processor is 1756L71 at firmware version 20. The Ethernet module, there's a control net module, another Ethernet module, and then a device net module. So it's going to give us all of this information that is found automatically for us and populated it into this system. It's going to tell us about a bit about the program inside of the PLC, more so to track a change to it than it is to, or to see that someone's done a download or an upload or something like that, than it is to give us a specific configuration. It's going to tell us the risks and vulnerabilities that it's automatically found for the PLC. So if it matches some of the vulnerabilities, it's going to go ahead and give us a risk associated with those. So for example, instead of us going to that site where we looked at earlier, it's actually publishing a risk associated with this device. I can expand it and get more details. And it's going to tell me about it, and it gives me the ability to address it myself and decide as an owner how I want to handle it. So I can mark it as open, I can mark it as completed. I can address each of these risks to make sure that I am following my steps within my timeline for completing this. If I click on these links, it's actually going to take me to the site we looked at earlier and tell me exactly about this. It'll take me to the knowledge base, and the Rockwell's knowledge base will talk about similar steps for remediating the issue. So this one has multiple vulnerabilities that we would want to address for our system. It's giving me 2 alerts on this. It's going to tell me that someone has done a port scan, and it's going to also tell me that someone has done a download. So someone has downloaded this processor, which may or may not be an issue, but it does highlight it for us as something we can address. Okay, if I go back to my asset list and stop focusing on the one and look at the group again, I can actually look at all of my Rockwell devices here, shown in various levels. Let's actually clear out from just Rockwell. Now I have a bunch of assets it's going to load. I have a lot of cameras in the system. What it's done for me is it's actually gone ahead and put these into communication layers. For anyone familiar with the Purdue model of networking, the Purdue model uses layers. The lowest layer being your sensors, the next being your control, such as PLCs, and then moving on to some of our higher level operations. If I expand this down, it's actually broken into levels for me. I can actually go back and see some of my devices that we were just looking at. So the chemical plant PLC. And if I want to understand more about what this is talking to, I can actually double click it, and it's going to show me the communications for this specific device. So it's going to tell me on my network with all of these devices. This is thinking about that bundled mess of cabling, condensing it down to seeing exactly what devices I have and what they're talking to. I can even start showing things like communication directions. This is going to show me directions that things are communicating together. If I want to, I can follow this to go right back to where my details about that device are. Also, within the automation, within Clarity, so it's going to show us a lot of information about our devices. It's going to also go on to tell us the warnings we talked about earlier. What are our highest risk assets? What are the, in this case, what are the assets we need to address first from a criticality? These are highly critical, and that is adjustable. That right now is based on the fact that they're PLCs. So PLCs are typically going to be very critical to operations. So how critical are they, and how much risk are they on? So they're very critical and have a high level of risk. We want to tackle these first in our process. We have unsecured protocols. So FTP is a protocol that's been around for a long time. It's an unsecure protocol by default. So it's going to pass unencrypted information that we can actually have risk associated with FTP. There are 52 assets with unpatched vulnerabilities. So we can go down each of these insights and start to track and find these. And like I said, it found these automatically for us. It's going to give us alerts. So we talked earlier about the download. There are some known threats. So this is an RS links issue that we want to go and address. There's just the Siemens issue as well. And there's actually a Trojan, so a type of attack. It's going to start highlighting all these for us. We were told a story by one of Rockwell's engineers that works with this product a lot, that they did a test on a customer site and actually found an instance of WannaCry sitting on the facility. Now, fortunately, it hadn't spread, but it was something that was actually sitting inside the facility, and with Clarity, they were able to see it right away. So something like that is very powerful for preventing an attack before it really spreads to be something worse. Now, you can dictate, when we start talking about segmentation again, there are physical ways to segment our devices with switches or even different physical networks, but there are also policies and zones you can make within the software. So you can actually come up with, you'll see that these are broken into different zones. These devices might be allowed to talk to each other. So you might be allowing things to talk to each other directly, but then give an alert if all of a sudden a device or a PC plugged into one side of the plant is talking to something that's entirely on the opposite side. They shouldn't normally talk. You might want to highlight that as a warning or a risk or something you want to go take a look at. And then you can also, when we talked earlier about who's going to do an attack and how are they going to do it, this is actually going to provide you with some details on potential attacks that could affect your equipment. So here's an example. This is what it considered the most threatened zone. There's a Siemens system here. So it's going to say that the PLC could be attacked in the following sequence. So they can use the external network to come in here, expose a vulnerability, and then attack the PLC. We can see similar with other systems. So if I go to PLC and Rockwell again, so using an RDP vulnerability, someone could come in and then use SIP commands to attack the PLC. So there are different ways they can do this. And what we would do when we start understanding attack vectors is, okay, what steps do we need to take between the PLC and this device, or between this device and this device, to stop that type of attack from happening? Once we say we're comfortable, we've stopped it, we can mark this as a completed exercise. And what I will say is, back to our presentation here, there's a lot there. So if anybody has any questions on Clarity, they want to see more about Clarity, that's something we can certainly come and we can talk about. That would typically be installed by Rockwell engineers on site as a system, but it's just part of the system. It's not no tool is an end all be all. It's part of a system. If you aren't sure yet, or if you just want to understand where you are before going with something like Clarity, what I will highlight is there are assessments available to utilize some of that same information. So for example, something like Clarity, where you collect the information about the site and you actually perform an assessment within the same engine that Clarity uses to understand how safe and secure your network is. So instead of an ongoing threat detection system, this is a little bit more like a snapshot. So a snapshot of how your system is today, what your key findings are, your biggest risks, how many assets you have, what your assets are. A lot of the single report type information is going to be provided within the assessment. It's not a punch list. It's not if you do these 10 things, you're now secure. Cybersecurity is more of an ongoing journey, but it is a highlight function to highlight. Is it something you need to invest a lot in? How close are you to being to the security level that you want to be? It'll tell you just where you are today. Now, past that, Rockwell does have consulting services available to help throughout this process. And we've seen this already. This is the before, during, and after. But if you wanted help on how to handle your patch management, so Rockwell does have a site where they actually list Microsoft patches as they come out. And it will detail whether they've been tested to work with the Rockwell system. So you could follow that as your patch management. Rockwell also offers this as a service where they will help you manage your patching. That's a pretty high level and advanced type of security. But Rockwell can help with this process. Talked about asset inventory. There can be remote monitoring to monitor your network for issues. Now, some people do this with various operations. Some might have a SOC, Security Operations Center. And then there are other vendors that can actually offer this service as well. And then, like we talked about, how do we have a plan around backup and recovery? So we said this a little bit ago, but there's a common model within cybersecurity. It's called defense in depth. And defense in depth means that one tool, one product isn't going to fully secure us. So when we're talking about the tools and services, we've talked a little bit now about, Clarity is a general tool. It's going to do continuous threat detection is what it calls it. So it's going to continuously be looking for threats. But we have other steps we have to take to protect ourselves as well. This is the defense in depth model, heavily used by the Department of Homeland Security, pushed by multiple vendors, a very good way to handle network security. And the reason for this is we might have the best possible firewall protection that we can have, but if we don't have good physical security, then somebody can walk right in the plant and damage our systems without even having to come through the internet or do something complicated over the network. So we need to have all of these together. We need to protect the devices, the applications, the computers that they're running on, the network that everything's connected to, and then physically our plant. And then the top one is just what rules do we have as a customer around the policies. So for defense in depth, there's a lot of different things we're going to have as part of this operation. And what I want to talk about is this is more of a network level protection that we can also just add to our systems. This one's going to apply to either smaller applications, so small applications, or a lot of times machine or skid level applications where you really want to protect a device that itself might not be secure. So we talked a little bit ago about the vulnerabilities affecting potentially Logix processors or even other PLCs. This can do multiple protocols. But let's say it's a Logix processor and there's a risk associated with one of the overflows or something that seems very technical, but when it's listing the risk, it's actually listing what ports an attacker would come on. So if we wanted to protect this insecure system, there are actual tools and guidelines built by Rockwell with Cisco for how to secure our systems. And this is a common diagram you may have seen before. It's part of the converged plant-wide Ethernet model. This was a collaboration between Rockwell and Cisco and now Panduit for a way to design a secure system that will provide the performance and functionality you need for an automation network. It's not the only way, but it is a tested and validated way to do this. So what they're showing here is they've got the each individual area for the machines broken into separate zones. So those zones are broken up, and they might have their own VLAN. They might be protected from something that happens in a different zone. And then you have a higher level, and this is starting to move up the Purdue model again. So we talked about the 0 to 3 and the 0 to 2 levels, and then levels 4 and 5. That's just talking about where we fit in the Purdue model, the higher level functions versus down at the bottom where we're talking about controlling sensors, and the top where we're controlling enterprise level information. As we move up security, we have individual zones, and then in the middle we saw something called a DMZ. So what this is meant to do is to protect the automation system from the enterprise network. The enterprise network is typically going to have more people, more devices on it. It might have people's laptops. It has email. It has something that is inherently more risky than what we would have on an automation network. So a DMZ is a common way of doing that. It doesn't mean that every customer is going to have this. There are levels of DMZ that you can apply. But what we're going to highlight right now is actually a much lower level function. In the bottom right corner, you'll see an IFW, industrial firewall, just protecting one zone. So if we think of this zone itself as possibly something that's insecure, has additional risks associated with it, we're going to focus on one of these devices. So traditionally, a firewall will protect one side from the other by limiting what devices, so who can come across and how they're going to do it. So in this example, local port 44818, that's SIP. That's Rockwell's port for communicating Ethernet IP traffic. So this can block who can access and how they're going to get there. So in this case, anybody trying to talk the SIP protocol, the firewall has an opening. But once they come through, we can't control what they're doing. It's basically saying as long as they're talking Ethernet IP, they're allowed. Well, something that's another offering, the Stratix 5950, is going to take it one step farther. It can do the who and the how. It can have the same type of rules for these devices can come across and use this port, but it can actually also control, even once somebody's in, what they can do. So this is an isolated type product where we're going to focus on an area or a smaller system, but we can actually protect when somebody goes down into that system what they're allowed to do. It uses something called deep packet inspection. So instead of just understanding like a typical firewall does where it came from and what port they're using, this is going to understand Ethernet IP. This understands SIP, and SIP is what Ethernet IP is built on, so Common Industrial Protocol. So it's going to understand, is the person trying to do a read? Are they trying to do a write? Are they trying to download to the PLC? Are they trying to change the firmware? It's going to understand that because it understands the traffic going across. And with that, you can actually build rules within the software to say whether or not something coming across from a particular IP address or network is allowed to make that change. So you're going to get way more granular control on what can be done. So I would see this being used on a machine and skid level, and also it potentially as an OEM who wanted to protect their device from unknown traffic or unknown changes to the environment. In this case, we're blocking anything with this admin level. So this is going to block anything that would be something like control flash to flash the firmware on the devices, or block downloads, uploads, block that RSLogix 5000 type traffic. And there's variable functions you can do here. You can allow reads and block writes. A lot of control you have within the 5950. It can operate in a few different ways. It can monitor what's happening and give alerts, and it can actually perform a true block. So it can actually block that traffic from going across. So this is just shown in a few different modes. This inline mode is going to be it's sitting an in and out network port to block traffic coming across it.